What's up guys, welcome back to the channel. In this particular video I will explain the problem print adjacency list. This problem is very easy and one of the basic problem if we want to get started with the graph. Starting with the problem statement, so it says that you are given an undirected graph with V nodes and E edges. Your task is to create and return an adjacency list of the graph, and it says that zero based indexing is followed everywhere. Okay, so guys, let me explain the problem with the given example. We are given a graph where we have 5 nodes and 7 edges. So V is basically representing the nodes and E is basically representing the edges. Okay, now guys, let me write the 5 nodes. So we are going to start from 0 because it says that 0 based indexing is followed, right? So the first node is going to be 0, then we have node 1, then we have node 2, after this we have node 3, and then finally we have node 4, right? And we are given the edges as well. So starting with the first edge, so it says that 0 and 1 are connected. And guys, see, this is an undirected graph, right? So when we say 0 and 1 are connected, so this is going to be a bidirectional edge. It basically means that from 0 we can go to 1 and from 1 we can go to 0. So 0 and 1 are connected with a bidirectional edge, right? Or with an undirected edge, both means the same. After this, the second edge is between 0 and 4. So 0 and 4 are also connected. After this, we have 4 and 1 connected, right? So this is the edge between 1 and 4. After this, we have 4 and 3 connected. So let me connect 4 and 3. Then we have 1 and 3 connected. So this is an edge between 1 and 3. After this, we have 1 and 2 connected, right? So let me draw an edge here. After this, we have one final edge which is between 3 and 2. So 3 and 2 are also connected. Now guys, this is the graph for the given set of edges that we have, right? Now this is about the given example, but our task is to write or create an adjacency list of this particular graph, right? So how we create an adjacency list? Guys, adjacency list is basically an alternative to the matrix representation where we have a n by n matrix or v cross v matrix, right? But here we will have the links represented by dynamic link list, right? So let me explain how we are going to create an adjacency list. First of all, we are going to start with 0. What are the nodes which are connected with 0? With 0, I have 1 connected, then I have 4 connected, right? So adjacency list of 0 will be 1 comma 4. These nodes are going to represent the link between 0 and like the edges of 0, right? So with 0 I have 1 and 4 connected. After this I have a node 1. What are the nodes connected with 1? I have 0, 4 and 3 and 2. Okay, all the nodes are connected with 1, so I'll start with 0, then I will have 2, then I have 3, then I have 4. I'm basically writing in the ascending order, right? So this is the adjacency list for 1. After this I have 2, right? So what is the adjacency list for 2? I have to find all the nodes which are connected with 2. I have 1, then I have 3. So I'll simply write 1 and 3, right? This is the adjacency list for 2. After this I have a node 3. So what are the nodes connected with 3? I have 4, 1 and 2, right? So I'll write 1, 2 and 4 because I'm going to write in ascending order, right? After this I have one final node which is 4. What are the nodes connected with 4? I have okay, so I have 0, 1 and 3, right? So I'll simply write 0, then 1 and 3, right? So guys, this is going to be adjacency list representation of the graph, and you can see that we have adjacency list for every node that we have, right? I have 0, then 1, then 2, then 3 and then 4, and even you can match this particular output with the given output that we have, right? This is the adjacency list for 0, then we have for 1, then we have for 2, 3 and 4, right? So guys, this is about the problem statement. I hope you have understood the problem well. So let's talk about the approach in detail in the solution part. Okay, so I have written the same example here as given in the problem statement. And guys, what I will do is I'll first start with the approach. Let me write approach here. After this, I will write the pseudocode in parallel as well. So I'll write the pseudocode, and then finally I will explain the implementation in C++, Java and Python, right? So guys, let me start with approach. See, we have a graph which contains 5 nodes, right? And then we have 7 edges. So let me write the 5 nodes as we are following zero based indexing according to the problem. So I'll write 0 first, then I'll write 1, then I'll write 2, then I will write 3, and then I will write 4, right? And guys, for each particular node, we are going to create a list which will represent the links of that particular node, right? And guys, in order to in order to understand better, I'm going to write the graph here as well. So let me quickly draw the graph. I have 0, then I have 1, then I have 2, then 3, and then 4, right? This is how we represent 5 nodes in zero based indexing, right? And now let me draw the edges as well. So I have 0 1 connected, then I have 0 4 connected, then I have 4 1 connected. After this I have 4 3 connected, then I have 1 3 connected. After this 1 2 connected, and then I have 3 2 connected, right? So this is the graph that we have. And guys, see, we are simply going to iterate over the edges, right? I have the first edge as 0 1. This basically means that 0 and 1 are connected, and as we are given an undirected graph in the problem statement, so it basically means that the graph is bidirectional, right? If 0 and 1 are connected, so from 0 I can go to 1, and from 1 I can go to 0, right? So guys, what I'll do is I'll simply write 1 in the adjacency list of 0, right? Why I'm writing 1? Because 0 is connected with 1, and I will also write 0 in the adjacency list of 1 because this is a bidirectional edge, so it basically means that 1 is also connected with 0, right? After this I have the second edge which is connecting 0 and 4, right? So I will write 4 as well, right? I will write 4 in the adjacency list of 0. It basically means that 1 and 4 are connected with 0, and I will write 0 in the adjacency list of 4 because this is a bidirectional edge, right? Okay, now I have 4 1 connected, so I will write 4 in the adjacency list of 1. So I will write 4 here, right? After this I will write 1 in the adjacency list of 4. This is how we are going to move. Then I have the fourth edge which is connecting 4 and 3, right? So I will simply write uh, 3 in the adjacency list of 4 and 4 in the adjacency list of 3. Now I hope you are getting an idea how we are going to write a adjacency list for every node, right? Then I have 1 3 connected. So guys, 1 3 are connected, right? So I'll simply write 3 in the adjacency list of 1 and 1 in the adjacency list of 3, right? So let me erase this because I want to maintain the ascending order as well. So I have 1 and then I have 4 as well, right? After this 1 2 are connected. It basically means that I have to write 1 here, and I have to write, okay, I have to write 2 here, right? Because 1 is connected with 2, and I have to write 1 here because 2 is connected with 1, right? Then we have finally 3 and 2 connected. So in the adjacency list of 3, I have to write 2 because 3 is connected with 2, and 2 is also connected with 3 because we have bidirectional edge, right? So I'll write 3 here. So this is how I can write the adjacency list representation for the given graph by just iterating over the edges. And now we are going to write the pseudocode by just writing some observations. See, the first observation is this particular adjacency list is going to be a 2D list, right? Why I'm saying 2D list? Because we have V nodes, right? We have V nodes. So you can think of these particular lines as a row, right? We have V rows total, and then for each row I have some columns. You can simply ignore this part, guys, because this part can be extracted out with indexing only. I will definitely explain this particular thing as well. But first of all, see, for each row we have some columns, right? We have some columns, and interestingly these columns are dynamic in nature. You can see that I have 2 columns here, I have 4 columns here, and this is what's special about adjacency list, guys, right? So now we are going to use this particular observation in order to write the pseudocode. See, first of all we need to declare an adjacency list, right? So we are simply going to write adjacency list adj is going to be a 2D list, right? Is going to be a 2D list. Okay, now for now I'm not concerned about size, but of course we are going to have uh, v columns, right? We are going to have v columns because we have v edges in total, and each edge is going to represent a row. Okay, so my bad, guys, we are going to have v rows, right? So we will do something like this. This is the syntax that we follow in Python, right? After this we are going to iterate over each edge. So let me write a loop for edge, uh, edge in edges, right? Edges is basically a 2D list again, and we are going to iterate over each as in edges, right? And guys, inside this we will find this value and this value. So we can find this value because edge is basically a 2D list. So I will write u equals to uh, edge of 0 and v equals to edge of 1, right? This is how we can get u and v. What are u and v? So guys, you can think of this particular node as u and this particular node as v, right? And when we say two nodes are connected, so we can generally represent these two nodes using u and v. For this particular case, u is going to be 4 and v is going to be 1, right? So this is how we can get u and v. After this, we have to add them in the adjacency list that we have, right? How we are going to add? So see guys, in the adjacency list of u, I will add v. So I'll write adj of u dot add v, right? what this will do is what this will do is it will add v in the adjacency list of u, right? So you can see that when we have 0 and 1 connected, so first I add 1 in the adjacency list of 0, so I add 1 here, and then I add 0 in the adjacency list of 1 as well, right? So I will write adj of v dot add u, right? Guys, this is the approach that we need to follow. Once this loop is complete, we just need to return adjacency list. This is the whole thing that we need to do. Once you have done this, your task is done. What is the time complexity? So the time complexity is going to be O of E, right? Because we are only iterating over edges. So now I hope you have understood the problem statement and the solution as well. So let me show you the code, guys. This is the code that we have. Okay, let me show you the C++ code as well. Guys, this is the code that we have. C++ code is on the left hand side and Java and Python code is on the right hand side. See what we are doing. First we declare a adjacency list to which is a 2D list, right? After this we just iterate over the edges, right? And we just find u and v. Okay, now guys, there is one different thing in C++. What we are doing is we are storing every edge in pair, right? So in pair we don't use indexing. Even we use like edge dot first, right? This is the method that we use to get every element of a pair, right? We have first element, then second element. After this we just do the same thing that I have already explained you. In the adjacency list of u I will add v, and in the adjacency list of v I will add u. This is the thing that we do only in case of undirected graph, guys, because we have bidirectional edge, right? When we have directed graph, so I just need to return this particular line. After this I just need to return a adjacency list. And guys, this is the code that we have in Java as well. We are just iterating over the edges and then we are adding the values, right? And this is the code in Python, guys. Now I hope you have understood everything related to this particular problem. So this is all about this video.